All right, so now we're going to take a look at example 2. So example 2 says, for the given linear function, determine the x and y intercepts. So very similar to what we just did in the last one. So we are given the equation 4x minus 3y equals negative 24. So first things first, let's find the x-intercept. It really doesn't matter the order that you do this, just usually we find x-intercept first. So to find the x-intercept, the very first step is to plug 0 in for y. So we have 4x minus 3 times 0 equals negative 24. As we have talked about, multiplying this 3 by 0 really is going to cancel that whole term out. So we're really just going to be left with 4x equals negative 24. If you want to go through and show the steps like I did in the last couple of problems, that multiplying the 3 by 0 is just 0 and subtracting 0 doesn't do anything, that's fine. You can show those steps in between, or you can just simply cross that piece out because multiplying by 0 really is just going to cancel everything out and make it 0. So it just leaves us with 4x equals negative 24. Now solving for x, we do the opposite of multiplication, which is division. So we divide the left and right side of the equal sign by 4, leaving us with x equals negative 6. And so our x-intercept is negative 6. So that's the first answer to our question. Now we want to go through and find the y-intercept. To find the y-intercept, it's a very similar process, but we plug 0 in for x and we solve for y. Plugging 0 in for x, very similar to what it did last time, is it's going to cancel out 4 times 0. 0 times 4 is just 0, which does nothing for us. It cancels it out. And it's going to leave us with negative 3y equals negative 24. Again, using the inverse operation of multiplication, which is division, I divide both sides by negative 3, and that leaves me with y equals 8. So this is going to tell me the y-intercept is y equals 8. Or in other words, where this graph crosses the y-axis is at a value of 8. From here, you could go through and graph these points and then connect them to get a picture of the equation 4x minus 3y equals negative 24. This problem only wanted us to find the values, not graph it, so we're going to leave this example as is. Now, I see that I have 2 example 2s here in the textbook, so that's a mistake on my end. So I'm going to go through the next example problem, which I apologize is also labeled as example 2. So this problem is 6x minus 4y equals 24. And on this one, we eventually want to graph this. So we're going to find our x and y intercepts just like we did in the last problem, but then we're going to end up graphing those points. I think now would be a great time if you're feeling pretty good at this and you want to try it on your own. I would recommend finding the x-intercepts on your own, pausing the video, and then pressing play to see me go through the problem. All right, so finding the x-intercepts is plugging 0 in for y. Oops, sorry about that. There we go. It got weirdly zoomed in. So we're going to have 6x minus 4 times 0 equals 24. We end up with 6x equals 24. When we multiply the 4 by 0, it cancels it out. Dividing by 6. And we find that we cross the x-axis at a value of x equaling 4. Now we want to find the y-intercepts. Or intercept, there's only one of them. We do this by plugging 0 in for x. Well, 6 times 0 is just 0, so it leaves us with negative 4y equals 24. Dividing by negative 4 to get y by itself. we find that we have a y-intercept of -6. So now I'm going to use that information to graph our equation. So I draw my x and y-axis. My y-axis needs to make it to -6. My x-axis needs to make it to a +4. And I label everything else, not that it's required, but just to keep it neat and organized. I'm going to graph the point x equals 4, so I'm going to plot a point on the x-axis at 4. I'm going to graph the y-intercept at -6, so plotting a point there. And then I'm going to connect them with as straight of a line as I can. Do your best. And there's the graph of the equation, 6x minus 4y equals 24, using x and y intercepts.